But these
everything
guys with Mojo, they've been working on this for a long time as well, right?
for 4 years. Yeah, yep.
4 years.
And not only that, I mean, these are the top people that know how to write really fast software that squeezes every ounce of power in that hardware. So I mean, these aren't like your average programmers. These are like the top 0.01%. Like, these are the most elite people.
Welcome to Practical AI, everybody. My name's Jeff. I'm here with Peter Lynn. Practical AI is brought to you by Pocket AI. Pocket AI is a tool you can use to edit the weights of your model. With Pocket AI, you can prune over 60% of the weights in your model without decreasing accuracy. One final note, we recommend listening to our podcast on 2x speed because Peter and I can sometimes talk pretty slowly. So, Peter, today we wanted to hit our hot topic, which is has to do with AMD. But before we do that, let's hit some AI fails, or at least one. And what's your AI fail of the week?
The big one, according to the internet, is Google's VO3, right? So like I think it was 4 weeks ago, Google had their Google I/O and they showed off VO3, which is their new AI for generating videos. And people have been trying it, and they have discovered that it's actually pretty terrible.
And where is it stumbling? What's
Oh, it's
the
something all over the place. The lip syncing is not in sync, so it looks like a bad, dub. You give it things, you give it dialogue, and the dialogue, doesn't actually match what the video is generated. You give it physics stuff like a fight, and it looks weird because the physics is wrong. Yeah,
Here's someone tried to recreate a Godfather scene, and
yeah,
because the script had casino, the word casino in it, it switched from the office, the home office, to casino as just
yeah.
one example of how it fails. So one of the things it's struggling with is dialogue. It just doesn't do dialogue very well.
No, it doesn't. That's a lot of people have been playing around with it. As long as your dialogue is super narrow and specific, it tends to be okay if it's really short. But if it's an actual dialogue that you want in a movie or a play, it ends up getting stumbled because it might think certain words in the dialogue it's supposed to change the scene to something else, right? So it's like if you were to give it Hamlet, Hamlet has this long monologue, and it probably would hallucinate, inject in things that have no relevance.
So it's having a hard time just in the context window determining what is prompt and what is dialogue.
Right, because it fundamentally does not understand that this is a dialogue.
And the other thing it's not good at right now is sound. Sound is terrible.
Yeah.
It's like echoey, and it's like
Yep, it's almost like it's trying to replicate like old film audio.
yeah, like sound studio type footsteps and stuff like that.
Yeah, no, it's dumb. It's like, I mean, it's a useful tool, but clearly Google cherry picked the best things to show and stitch together for their Google I/O video.
Got it. All right. So before we leave the VO side of stuff, do you feel like VO is a big step in the right direction, and we're just being critical because it's not what everything we want it to be, or do you think that this is somewhat of a fail?
I think it's good progress, but until the models understand physics, like I've done experiments where, like I'll describe, I'll say a cherry blossom petal falls onto a stream, and it flows over a couple of waterfalls, and it's completely wrong. It's just physics is completely just not even right. It's nowhere near right. So that's the first thing is physics has to be understood by the models, and right now it doesn't.
Well, we'll follow up with more questions on this later because Can it ever understand physics? Is it just memorizing stuff? But we'll leave that for another discussion. Okay, so let's
Yeah.
move on to our hot topic and kind of a win at the same time, and that is AMD. Tell us a little bit about what AMD is doing and why they're kind of in the win column right now.
So AMD for the last, I think, I would say year and a half has released new chips called the MI series for doing kind of inference workloads, and so they've been winning, which is nice. And so that's a big win for them. They're seeing kind of people adopting their GPUs for kind of runtime inference. So that's nice. That's a big win because before that, like people were asking like, "Hey, AMD, like you're losing out on the market here." And so this MI 350, it's the first one that kind of really is starting to get good adoption.
Okay, and you said that it's being used for inference. They're not using this for training right now.
From what I hear, I mean, most people are using it just for runtime inference and not used for training yet.
Okay, why is that? Why would someone use a model for training and not inference, and inference and not training?
Well, so training is a kind of a long process, whereas inference, it's variable. It's you and me using GPT or using Claude or using whatever, right? And so that load, what you want is you want to load that model onto one chip, ideally, so that if you want to serve 10,000 people, that's 10,000 chips. Whereas if you're using something like NVIDIA's stuff, well, okay, if the maximum amount of memory is 64 gigs, you need multiple chips now. You need multiple cards. And so now it's one person has to use several cards. And so now you gotta do this thing called time sharing where if you send a prompt first for me, I'm gonna have to wait till your prompt is done before mine gets processed.
Okay, and there's another company we've talked about. We've covered the Grok hardware, not to be confused with X's Grok model. But Grok hardware is also focusing on the runtime space. And how are they different than what AMD is doing? And what do you see between the competition there in the
So,
inference space?
yeah, they're fundamentally different. Grok hardware is based on the idea that one, we're gonna have smaller chips that do kind of this matrix math thing very quickly, but there's also static memory right next to it. And so instead of what AMD and NVIDIA do, which is you get these GPUs and you get a huge amount of high bandwidth memory, HBM, they're saying, well, HBM, there's a limited supply. Like, there's only so much made every year. And so if you want to build more chips, you actually can't because that's your limit. Like, if there's only like 10 million units of HBM memory, that's like, it's a hard limit. You can't just wish away more memory. But Grok says, okay, well, we'll use static memory, SRAM, and we'll make these smaller chips, and we'll just make like tens of thousands of chips really close together. And so it's really designed for transformers. Downside is when the technology changes and transformers is no longer dominant, their hardware won't be as efficient because they,
Oh,
they make choices based on transformers.
okay. So any of the other machine learning methods, it's going to be difficult for Grok hardware to
Yeah.
participate.
It'll
Okay,
still run, it just won't run as fast and it might run slower.
got it. Okay, so but the our friends over at AMD long been considered as a potential to at least keep up with NVIDIA. They are making some headway then on their um, software stack. So tell us a little bit about what they're doing and why they could possibly catch up.
So AMD actually didn't build this. So this is Mojo, which is a language created by Chris Latner. I mean, he's famous for LLVM, Swift language, and LLVM is used by Rust and a couple other popular languages. So he's not part of AMD. He used to lead the Swift language development at Apple. He left and then worked at Google for a couple of years trying to solve the same problem of like we need to run these models very quickly. And through that pain process of figuring out like, okay, well, we got to run on a TPU now, but also run on a GPU, and it's like some workloads have to be on the CPU, and he's thinking like, okay, how do we solve this better? So he spent the last 4 years working on Mojo, which is Pythonic, meaning that the language itself looks like Python, but underneath it's completely new. It's written so that you can target any hardware that they support, and it'll run as fast as possible.
So this video is using Mojo on top of AMD hardware,
Yeah.
but this will work on top of NVIDIA hardware as well.
Yes. Yep.
Okay, so in a sense, this from a NVIDIA perspective, this would sit in the level or the layer of CUDA, correct?
Right. Yeah. But the catch is this is really just focused on machine learning models. So if you want to do something different, this isn't built for that. So this is just really for ML stuff.
Okay, so it doesn't come with all of the built-in libraries for genetic and protein processing and all that stuff, right? It's just
Yeah. No.
ML.
It's, yeah. Yep.
Okay. And when we were talking about this a couple weeks ago, you were saying if someone's going to try to rebuild CUDA with all those libraries and all that, slick work, relating to the hardware and stuff, it would take a long time. But these
Every
guys with Mojo, they've been working on this for a long time as well, right?
4 years. Yeah. Yep.
4 years.
And not only that, I mean, these are the top people that know how to write really fast software that squeezes every ounce of power in that hardware. So I mean, these aren't like your average programmers. These are like the top 0.01%. Like, these are the most elite people.
These guys aren't using Claude to write their code and then not debugging it.
No, no, these guys are writing really hardcore C++ code, and like they know all the tricks about. Okay, we've got this huge batch of calculations. How do we parallelize this? How do we chunk it up? How do we divide it? How do we run it on both CPU and GPU or TPU or whatever, right? So I mean, like this is kind of really hard stuff that very few people have the knowledge, and they have it.
So, do you think the Mojo software will be a significant improvement to the ML industry?
I think it'll give people more options, which will be good, and I think ultimately it'll force NVIDIA to kind of take notice.
In what way?
Well, right now NVIDIA is king, and if you look at the quarterly earnings, they are king.
Yeah, yeah,
And
yeah.
they're booked out for the next 12 to 16 months, which most companies wish they could be in that position of like their hardware is just like, hey, if you want to buy something, you got to wait 18 months because we're booked up.
But it sounds like, well, let me ask this question. Is NVIDIA the king because of their hardware or because of their software?
It's both. It's both because with every generation they change the hardware, but what makes it easy for you to like move your code from something like the H100 to the Broadwell chips is that they've done the hard work of like, okay, you use the same software, under the hood, it's going to this new hardware that's completely different.
Does that mean that Mojo will always be like one release behind, where they got to get into the new release or the new hardware and then figure out how to
Yes.
make their software connect? Okay.
Yeah. So they'll always be, I'm going to guess, 4 to 6 months behind, which isn't bad.
Yeah. Well, especially if the price of the new stuff is always, 3x the old stuff. Some people just may want to stay on the old stuff.
Yep.
Yeah. All right. Yeah, this is cool. It's fun to see some of the software stuff starting to echo a little bit now. It's the software story is becoming more and more valuable and more interesting, and
Yeah.
we're hopefully here to report on it. All right, Peter, thank you. This is great. You can follow us also on Spotify. We're there if you just like the audio version. If you got any ideas for stuff we can talk about, let us know. In the meantime, we'll put these videos in the notes box, and you can check them out there. Thanks, everybody.